Welcome to this introduction to Micronaut talk. This is the second talk on Micronaut today. Earlier, Ivan Lopez delivered a Micronaut in action talk, which covered some live coding and demos of Micronaut and what it's all about. So I'm not going to go over the same ground. What I'm going to go over is why Micronaut, the design philosophy of Micronaut, how Micronaut works, and make a few announcements and do some code demos and as well different code demos and so it should be exciting. So let's see. Hopefully the demo gods are with me today. And for those who don't know me, my name is Graeme Rocher. I created a framework over 10 years ago, which some of you may have heard of, called Grails. And which is also amazing. And I'm also the creator of Micronaut. I wrote the original book on Grails, the Definitive Guide to Grails. And my career path followed Spring Source, VMware. I used to work for Pivotal. I'm now a software engineer at Object Computing, so that's our website. And this year, I was lucky enough to be selected for the Oracle Groundbreaker Award. 2018, so I felt a little bit out of place, standing there next to the creator of Python and Kafka and stuff like that. But it was certainly a privilege, and thank you to the kind folks at Oracle for considering me for the award. On the agenda today, we're going to talk about how we got to where we are today, microservices challenges, the microservice landscape. We'll do some Micronaut demos, make some announcements, talk about the roadmap, and hopefully you'll take some useful information away. So in terms of how we got here, in 2008, 10 years ago, a heck of a lot has changed in that time, both technologically and otherwise. So 10 years ago, that was when Grails 1.0 came out. It was a very different technological landscape. Everybody was building monoliths. What I was saying, everybody was building monoliths, and there was, the JavaScript frameworks out there hadn't reached the maturity level that they are at today in terms of things like Angular and React and Docker. And there was no Docker, there was no microservices, so completely different landscape from then to now. And in that intervening period, I think the Java ecosystem have tried to adapt to the requirements of microservices by essentially adapting existing legacy technologies. And if you look at technologies like Spring and Jakarta and so forth, they were never really optimized for low memory footprint microservices. They were designed at a time when monoliths were all the rage, and where it was okay to use gigabytes of memory and everything would be fine. Nowadays, when we talk about low memory footprints, microservices, and serverless functions, the runtime characteristics of a typical Java application using existing tools is not as acceptable as it once was. So there's been this adaptation process, and we still haven't got there. And when we looked at this problem over a year ago, we started to analyze the problem. And we came to this decision point, this inflection point, where we said, okay, we can try and convince people, that they can run Grails, they can run Spring on microservices and low memory footprint microservices and functions, and everything will be okay. Or, we can go back to the drawing board. And that's exactly what we did with Micronaut. So the goals of Micronaut were to create a new framework that was designed from the ground up with microservice and serverless computing in mind. So the priorities for the framework were blazing fast startup time, low memory footprint, as small as possible jar sizes, 0 external dependencies, should be 12-factor out of the box. And before we undertook this, we undertook an analysis of Spring and Grails and the challenges to using them to build truly low memory footprint applications with small amounts of startup time. And really, Spring is an amazing technical achievement. There's no doubt about that. and it's immensely popular and so forth. But it does a lot of things for you, and it does them at runtime. So what does that mean? If you look at the internals of Spring, some of the things that it does is it will load all of your class files that are beans, and it will read the bytecode of every beat it finds. Because it's not enough to just use a reflection with Spring. It has to soft load your classes and read the annotation metadata to know if the class is loadable or not, and so forth. So it actually reads your .classes files at runtime. It then synthesizes a completely new annotation set that is not the real annotations, it's kind of the meta annotations to deal with stereotypes and meta annotations, and is this annotation annotated with that annotation? And it does so for each bean, method, constructor, field, so forth, in order to support annotation metadata. So if you think about this, each bean, method, constructor, field, that's fine for like hello world. There's been a lot of comparisons of, oh look, a Java Jakarta EE app or a Spring app starts up in few seconds for hello world. But that's not so fine when you have to analyze deep inheritance hierarchies where you have lots of source files. It's not just about the number of classes, it's about the size of your bytecode. The bigger the Java class, the more work Spring has to do. It has to traverse into your bytecode through ASM, searching through all the injection points, finding all the meta annotation data, and build all the reflection metadata for each bean, for every method, constructor, and field. And it's basically technically impossible to achieve lower memory consumption with this model. What you see is that you have this correlation between lines of code and startup time and memory consumption in a typical Jakarta EE or Spring codebase, and a Grails codebase, of course, because it's based on it. As your application grows in size, so does your startup time and your memory consumption requirements. And there's an irreconcilable tension between this problem, because it's technically not solvable with current models. And what this has led to in the Java world is this split between different kinds of frameworks that do different things. And in the one corner, in the lower left-hand corner there, you have these low memory consumption, fast startup time frameworks that I like to call do-it-yourself toolkits. Now, there's real value in these toolkits. There's no taking anything away from Vertex or Ratpack or Spark. They are useful for a lot of scenarios, particularly if you want to get low level and you want to eke out the maximum performance and so forth. But the majority of developers out there in the world are most certainly using the top right corner frameworks, which is Spring, Jakarta EE, Grails, so forth, because they provide a lot of an opinionated view with a lot of packed full of auto configurations and integrations. People love getting up and started quickly, love the productivity that they provide. But they come with high memory consumption and startup time compromises. So you kind of have to choose like one or the other if you want like your declarative transaction management with transactional, then you have to go for high memory consumption. So we thought we sort of looked at this problem and like, why does it have to be this way? It shouldn't have to be this way. And the micro reality is that frameworks that are based on reflection and annotations become fat. And there's no way with current models to solve that. You cannot use reflection and analyze annotations at runtime and create an application that is low on memory. It's technically impossible. So, but we do love the programming model. People love things like Spring. They love Jakarta EE. So people live with it. But so a question to ask yourself is, why should we be more efficient? And this is not so much about like Micronaut versus Spring versus Jakarta EE. It's more about where the industry is going. So a question I ask people, Java people, is imagine if Kubernetes or Docker had been written in Spring or Jakarta EE. Imagine that for a moment. All of us would need a supercomputer to run them locally, right? Now, there are other reasons that Golang was chosen for the systems programming level features and so forth are compelling. But if we, as a Java industry, do not adapt to become more efficient, then folks are going to end up using things like Go, things like Node, and things like that fulfill the small startup time and low memory consumption requirements. It's already happening, and we need to open our eyes to it as a Java industry. So this is something that we considered. And the thing about this is a lot of these problems that I'm describing right now are already solved with something called ahead-of-time compilation. So in the Android community, this is old news. Android already solved this problem because they have the same requirements as to run in low memory consumption and startup time. It's not acceptable for an Android application to take forever to load and to consume a heck of a lot of memory. So there's something called a Google Dagger, which is used extensively in the Android community. It's a dependency, compile-time dependency injector. It's reflection-free. It's very much like Juice, and it's limited in scope to just DI. But it's very fast, very performant, and consumes very little memory. Now, it's a shame that these kind of tools exist, but they're not. But something like this had not been adapted for the server side. So that's exactly what we did with Micronaut. So what is Micronaut? Micronaut is essentially a ahead-of-time compilation framework. It's designed from the ground up with microservices in mind. So we built it explicitly with the idea of creating as low as possible memory footprint microservices with JVM. It's ultra lightweight and reactive. You can write reactive applications or traditional applications. It's based on Netty. For blocking operations, we have a separate thread pool where we shift blocking operations to. In our benchmarks, even Netty processing blocking operations is still faster than your typical Spring Tomcat server for a similar style application, for example, a JDBC application. It uses ahead-of-time compilation to pre-compute all framework infrastructure. So everything that Jakarta EE and Spring do at runtime happens at compilation time with Micronaut. And that's the critical thing. So, not every technology is perfect. Obviously, I'm here talking about Micronaut. There are advantages and disadvantages. So, in terms of ahead-of-time compilation, what you're doing here is you're paying the price at compilation time to gain speed at runtime. Yeah, but if you think about it, in a microservices architecture and in a serverless world where you're creating small application units, that very tiny delay in compilation time is worth the cost associated with gaining all the memory performance at runtime. It's a HTTP client and an HTTP server. We have support for multiple languages, Java, Kotlin, and Groovy. And I'm going to demonstrate some of the things that Micronaut computes ahead of time. I'm not going to go into building a brand new Micronaut app and demoing all of that. Like I said, Ivan already covered that. But let's take a look at what Micronaut does. So hold on. Right, so this is a typical Micronaut application. And as you can see, it's got an application class, which you can run. It's just a main class, that's the model. So perfectly suitable for things like Docker containers and embedded application, you can run it. If I run this application, you'll see that the application will start up very quickly, 1.2 seconds in this case. And if you look at the tests, it's a simple hello world example with a client. This client here is an interface, and Micronaut will at compilation time compute the implementation of the interface. So there's no implementation of this class. It's an interface decoratively defined to talk to my service, and it's declared as retryable, so that it will retry for a certain amount of test times before failing. And you can see that we have full support for annotation metadata, referencing configuration values, and so forth. And it's reactive, so it's returning a single. And if I run this test, which is using our testing framework called Micronaut test, you'll see that I'm able to annotate any JUnit 5 test or Spock test with @Micronaut test. And then I can just use @inject to inject the client. And I can call my server. And what you end up seeing is that your test execution becomes extremely fast. And things just happen a lot faster with Micronaut. So there's this kind of artificial division in the Java world where you have functional tests which you write less of because they're super slow to run and everything starts up slow, and so you end up writing lots of little unit tests because our frameworks and tools are so slow. And that's one of the things we want to really solve with the Micronaut is why shouldn't people writing more functional tests? The functional tests are in a lot of ways superior to unit tests. And we often make a decision about writing a unit test or a functional test based on the performance of the test. That factor shouldn't be something in the decision making. It should be you should write the best test for the case that you're trying to do. And you can see that this test here is actually using my client, making a remote call to my Hello controller, and it's all real live things happening. So how is it possible that this is so fast and consumes so little memory? Well, if you look at the at the build of this project, you'll notice that we have a few annotation processes set up. So one of them is Micronaut inject Java, and that's the key dependency injection annotation processor. And then another one is Micronaut validation. Micronaut validation is an interesting one because a lot of frameworks will fail at runtime for things that should really be picked up by the compiler. So, for example, if I referenced, I'm referencing a URI variable called name here, and with this parameter, see that there's a link between the two. And if I were to misspell this in Micronaut, that would be a compilation error because we validate your URI roots. Whilst in a traditional framework, that would be a runtime error. And you'd have to go in, oh, my root is failing because name doesn't match up and whatever. So we're able to validate your code at compilation time and ensure that things are not working properly before your application is running. So it's basically, that's how you set up. And this is a Gradle build, but we have a project generator that will generate a Maven build if you want with the same annotation processor set up for you. And what that enables is Micronaut to produce an additional set of classes. So if we look at the Hello controller, it's got some interesting aspects here. You can see that it's referencing a greeting service. The greeting service is injected. It's calling that greeting service. In addition, it's got some @controller annotations. It's got @get over there. So what actually happens is at compilation time, Micronaut will produce an additional set of classes that sit alongside your classes. So if you look here, you can see that I've got my classes that are produced from my application. And then you got these classes here, which are Micronaut-produced classes. And this is your framework infrastructure. These Micronaut-produced classes are what Spring and Jakarta EE do at runtime. They are the pre-computation of your application annotation metadata, of your application dependency injection. For example, if I open up using the IntelliJ decompiler, I can decompile this, and you can see that if I find the constructor, you can see that Hello controller is being newed up directly, completely reflection-free, without having to reflect on anything, without having to read and store and deal with reflection metadata. It's calling new Hello controller and injecting the greeting service by looking it up and then returning that greeting service directly. This is essentially like a bean factory in Spring, but produced at compilation time. And you can also see that the annotation metadata for the controller is produced at compilation time. So even the class loading requirements are produced ahead of time. So you can see we have these internal methods like load class value, which directly load the classes so that the JVM can inline those class loading calls and avoid class.4name, because class.4name is expensive. So with Micronaut, there's no class.4name, which is another reason why it runs so well on GraalVM, which I'll get to in a moment, because the class loading is not as dynamic. All the annotation metadata is computed ahead of time. It's interned using string interning, and everything that Spring does, and even like reflective logic, you can see like most frameworks will do reflection, so they will get hold of a method reference and they will invoke your controller reflectively. But Micronaut doesn't even do that. It generates at compilation time executable methods that are able to directly invoke the controller's hello method without using reflection. Again, this is another reason that Micronaut runs so well on Graal, because there's absolutely zero reflection in the entire framework. And the annotation metadata is also produced for each method. You can see that we're reading all the annotation, so we know about all the annotation metadata, and it's computed ahead of time and soft loaded on demand. So things that are extremely fast and efficient. So what is the result of that? Well, if we look at my application, and I make this a whole lot bigger, I can assemble this and it'll build my application and create my bean definitions at compilation time. You can see it doing there. It's shadow jarring it up. Now, if I do java/jar build list hello world Java, I might actually need to double check that I don't have the application still running. Let me just, yeah, I do have it all still running. So I'm going to do the fast way and just do kill all -9 Java. I got logging enabled, and something is still running. Enable the server. Let's see. What I'm going to do is I'm just going to run it on a different port. So let's just change the port number and rebuild the application. And we're going to run it on a different port, so we avoid that scenario. Okay, so I think I'm using the wrong. Yeah. Hold on, I'm looking at a completely different application probably. Let's. Yeah, I'm not even looking at the right application. Okay, so let's rebuild that. And what you get is basically, once I've built that application up, I can run it as a jar file. There we go. And there we go, it's startup completed. I could reduce logging, which would make a whole lot of sense. I have trace logging enabled. And so we can actually see something more interesting. Okay, so now, there we go. So that's better. So the application starts up. Now the interesting thing is that the application starts up fine. It's using very little memory. But what's even more interesting is that you can limit the application. Now, if you try and run a Spring or any other kind of application with XMS 13 megabyte, for example, or something like that, you're going to have problems with the application even being able to start up, and in this case, yes. I think because I'm using a Hibernate validator. I blame Emmanuel. So yeah. Hold on, let's get Hibernated validator requires a little bit more. Hold on. There we go. 16 megabytes. Let's go with 18 just in case. But yeah, there you go. Application started up. And again, everything computed ahead of time. As we migrate to more and more of the internals of things like hibernated validator to use not reflection, you'll be able to see that less and less memory will be required to run the application. For example, if I comment out hibernated validator and rebuild the application, you'll see that I'm able to compute the application and execute it in any even less memory than before. So, as I said, frameworks and libraries need to adapt to Micronaut, and more of Micronaut needs to be computed at compile time. But once we've arrived to that point where more things are computed ahead of time with ahead-of-time compilation, we'll be able to get to the point where things are using a lot less memory. So Micronaut is, like I said, both a Hello controller and a Hello client, and it's also extremely small. So if we look at the jar file size in this application, that's the other thing that's interesting, is that hold on. If we look at the jar file size, you can see that the application jar is only 12 megabyte. The built application jar is very small. So the unit size of your application is much smaller, which is critical. Yeah. So actually, that would be why. I'm using GraalVM. So this is what happens when you have lots of different JVMs out there, is that GraalVM's memory requirements are slightly higher than your typical JDK. So if I do SDK, use Java, some other Java version, and run my application, you can see that the application starts up. So there I was blaming hibernated validator, but it's actually GraalVM that was consuming more memory. Yay! So yeah, lots of memory consumption tweaks that you can do to get it even lower. In this case, I'm using XMX12. I think I could even take it down to 10 megabyte if I really want to push the boundaries of what's possible. But the application is still starting up with XMX10. I could probably even take it down to 7, and it might even start up. Oh, it's still starting up. So XMS 7 megabyte. The application is still starting up, and it's still working fine. Hello, John. Yeah. Oops. Suppose I should do a curl. There you go. Yeah, I'm using XMS 7 megabyte, and my application is still starting up. Yeah, and still responding and still operational. So that's the revolution. And yes, the JVM that you use does actually matter. Apologies for that. So yeah, very low memory consumption requirements, and heap can, as you can see, be as little as 12 max heap. I actually put a conservative figure in there in my slides, but as you can see, even with 7 megabyte, you're able to do it. Startup time is around a second for Kotlin and Java, a little bit more for Groovy. All DI, all AOP, all proxy generation happened at compilation time. Micronaut will compute all dependency injection, all annotation metadata, all AOP proxies, everything that's framework infrastructure will be computed ahead of time. So, like I said before, if we had only set out to build an HTTP server, then Micronaut would not be very interesting. Micronaut is a lot more than an HTTP server. It's trying to completely change the way we build applications to be more efficient, completely alter the runtime memory consumption model of your typical Java application. It's also got a whole bunch of other cool features like service discovery, like console, like Eureka, Route 55, configuration sharing, client-side load balancing, integrated Netflix, ribbon support for serverless computing and FAS. It's really pretty cool. And whilst I've been doing this whole presentation, I actually have a little Micronaut, which I'm going to open up here, federation running. So this application is the pet store application that we demo, that we provide as part of Micronaut. And this thing has been running on my machine the whole time. And it's made up of like about 8 different microservices. And notice like my machine is not exploding. Nothing is, the fan is not flying. Like the application is running perfectly fine in the background without destroying my CPU. And it's been there the whole time. It's a little pet store app, and what you can do with it is it demonstrates like different backend implementations. So one database is Neo4j, one database is MongoDB, one database is a relational database, and they basically allow for different different languages as well. So you got one written in Groovy, one written in Java, one written in Kotlin, and it's a good showcase of what Micronaut is capable of. And one thing you can do is you can go in here and you can say docker compose pause mail. You can see that there's a mail form here, and oops, I probably need it to be in the right directory. It's in this one. Docker compose pause mail, and you can see that the mail form has paused, and look, it disappears. Yeah. So this demonstrates as well like graceful degradation. The UI is using React, so just by pausing the mail service, the mail form disappears. I can no longer send emails, and then if I unpause mail, you can see that it comes back, and my form is back, and I can send emails again. So demonstrating again the whole graceful degradation of your microservice infrastructure. So that is the Micronaut pet store. You can also write functions and run them locally or as regular server applications. You can deploy to AWS Lambda, and after warm-up, functions execute in milliseconds. We have support for GraalVM. So GraalVM is a new polyglot VM from Oracle that runs JS, Java, Ruby, and R. The ability to turn Java code into native code, and it's really an impressive piece of technology. Ivan demonstrated it earlier. It's obviously still experimental stage at this time. But because Micronaut is computed all ahead of time with zero reflection and very little use of dynamic class loading, there is a higher probability that you can build a Micronaut application and have it operational with Graal. There's something called Graal native that will take your Java application and compute it into a native image, which adds even more startup improvements. So in terms of Micronaut and Graal, GraalVM itself is, like I said, at the experimental phase, as is Micronaut's support for it. But because of the way Micronaut works, it's a far better fit for use with Graal than any other existing framework. And we already have more working on GraalVM than any other framework. So with Micronaut, our HTTP server is working, our client, HTTP client is working, the serverless functions are working, service discovery is working, all dependency injection and AOP is working. The only parts that are not really working with Graal is if you involve any third-party libraries. Yeah. So if you stick to just Micronaut libraries and Micronaut, then you can write applications that are fully Graal compatible today. And one of the things that, like I said, Micronaut is a framework for ahead-of-time compilation. And one of the things that we announced a couple of days ago is Micronaut for Spring. And I'm going to be demonstrating it for the first time in it's this audience. What it allows you to do is, using ahead-of-time compilation, compute a Spring Boot application, which is a valid, essentially at the source level, Spring Boot application, into a Micronaut application at compilation time using AOT. So there's no runtime overhead. I think if there's one thing that Micronaut is really revolutionizing and completely changing is the separation between what is the source code and what is the runtime environment. We can now interpret any source code because we do pre-compute at the source level. So the fact that it's using Spring annotations is irrelevant. There's no runtime overhead to analyzing those annotations because all we do is take that annotation metadata and map it to something else. So we are able to compute a Spring Boot application into a Micronaut application. And this brings a whole lot of benefits. Suddenly, IDE support improves for Micronaut. And you can build applications that support Spring, Micronaut, and Grails. So if you have an existing investment in one of these frameworks, this is a win-win situation. This is the project URL. And what I'm going to demonstrate to you here is you can see you can see that here. Hold on. Here it is. Okay, so this application here is, if we look at the source code, it is a Spring Boot application. We have an application class that is annotated with @Spring Boot application. The only difference is we're doing Micronaut.run instead of Spring Boot.run. It has a configuration properties that is an @configuration properties from Spring Boot. It's an @component. It has a controller that is a Spring REST controller. It's using get mapping from Spring. It's using post mapping. It has a scheduled job that is an @component that's annotated with @scheduled. It has another service over here that is @validated from Spring. There's literally the only reference to Micronaut in this application is this line here. And this application is completely executable with Micronaut. So I can run tests, and I get the same instantaneous test execution experience for running multiple different tests. Look how fast those tests run. Exceptional test execution speed. I can take this application and I can run it as well, and I get the same amazing startup performance and low memory consumption. It is essentially a Micronaut application at runtime. And but I also get all the benefits of the IDE support. So I can open up application.yaml in IntelliJ, and I can come in here and I can do things like application.default charset.utf. I'm getting full code completion here for all of my configuration properties. I want to set the number of worker threads to 10 in Netty. I want to click navigate into where this configuration value is defined. Go back. The IDE, as far as the IDE is concerned, this is a Spring application. So even though at runtime it's computed into a Micronaut application. We have views as well with time leaf, view rendering, and the same ahead of time computed data is there for this. There it is. Well, that's all the Micronaut stuff ahead of time computed for this application. And what this effectively means is that you can then take this application, compute it into a native image on GraalVM, which I have already done, so that we don't waste time with the GraalVM compiler. And this is the same application, but using ahead of time compilation and GraalVM to compute it. Oops, I have it running. So gonna stop it. Hold on. I think I know what's going on here. I am going to stop my Docker Compose. Docker Compose. Down. It's my pet clinic application that is occupying port 8080. So once that's up and running, once that's down, in fact, which will take Docker a few minutes to bring it down. Let's see if it's already done. Oh, it's already done. Okay, so you can see that the Spring application is computed into a Micronaut application and then compiled into a GraalVM application. So you get instantaneous 19 millisecond startup times. If we look at the actual resource usage in terms of memory, let's have a look. You can see there it's using 16 megabyte of memory, very little amounts of memory, and the application is essentially a Spring application. So I think it's pretty remarkable that with Micronaut we have the ability to run Spring Boot applications on GraalVM before the team from SpringSource, which is pretty cool, by essentially computing your source code into a Micronaut application ahead of time. So I think that's pretty cool. And Micronaut for Spring has the intention to take the Spring programming model to new places. Because we have detached what is the source code, relevant source code from the runtime, Spring can be used in places that it was never possible before. I mean, Spring, there was always nice, the idea of using it on Android, but the performance and the memory consumption was so bad that that was impossible. It can go to Android, it can go to GraalVM, it can run on serverless. So I think that this completely changes what you can use Spring for, and what is essentially the Spring DSL. Now, you can argue, is it really a Spring application at runtime? Well, what is a Spring application? At the source code level, it's a Spring application, right? So that's the question. And if more and more of the Spring ecosystem adapts to Micronaut, basically it'll mean that a whole bunch of doors are opened in terms of using Android and AOT, IoT scenarios as well. We have Micronaut running on the baby Raspberry Pi. Yeah, the little Raspberry Pi, the lowest spec one. It runs fine on the. We have a little setup with a whole bunch of Raspberry Pis, and it works wonderfully. So Micronaut has this ability to go places which traditional models have not been able to do. Anyway, so Micronaut 1.0 is out now. It has compile time DI, and AOP, HTTP client and server, service discovery, distributed tracing, serverless functions, data access, auto configurations for SQL, MongoDB, Redis, and Cassandra. We have Micronaut 1.0 available on SDK Man, so you can just do SDK install Micronaut. The project is healthy, 2 years of development by several OCI engineers and external contributors, 70 external contributors already. We are on 1,300 stars, and that's going up. If you are in this room, do star us. The repo is there. We're doing phenomenally well, and 1.0 is solid. We're already using it in production with clients of ours, and we think it's awesome. And in terms of the roadmap, Micronaut for Spring will go GA very soon. If you actually look at the source code for Micronaut for Spring, the remarkable thing about it is that there's very little of it. It's literally just a bunch of annotation mappers that map one annotation value to another annotation value at compilation time. There's very little code there. So going GA is not going to take very long. We can add things that are, there are a few interface bridges so that we can make things work better, but it's very little code. We're going to do a lot of AOT improvements. Like I said, we're just touching the surface of what is possible on AOT, but there's a whole bunch of things that we can do. I mentioned Hibernate Validator. We want to make it possible with the Hibernate Validator team to use completely reflection-free validation, if possible. We want to make it possible to do data binding with this, which is completely reflection-free. We want to make sure that things like Jackson marshalling from objects can be completely reflection-free. And we have, Micronaut is a framework for AOT. We have already the ability to do all of this stuff and an API for doing it, and it's ready to go. We're just going to be incrementally improving it until our goal is to essentially remove every single piece of reflection ever done in a server-side Java application. Because, like I said, there's an unsolvable conflict between trying to be memory efficient and using reflection. It's not possible. It's technically not possible. You literally have to cache that reflective data because it's slow. So we also have support for OpenID Connect coming up. We have support for RabbitMQ coming up. We're working with the Google guys for better GCP support, which we're excited about. We're gonna have support for building gRPC applications. Remember, Micronaut is a general application platform. It may have an HTTP server now, an HTTP client now, but we have people using it to write message-driven applications with Kafka and CLI applications and all sorts of things. There's a whole bunch of applicable possibilities with Micronaut. You can check out the project roadmap there. There's a Git community, that's the link there. The user guide documentation is already very comprehensive, but we have a guides page as well. The FAQ is there, the repo is there, please start. The examples, you can find at that repo over there at the bottom. We have a bunch. There's also an events page where you can get a whole bunch of additional Micronaut events coming up. The closest one is next year, in DevNexus coming up soon, and Micronaut Summit and so forth. So anyway, as I said, Micronaut aims to provide the same wow factor for microservices that Grails did for monoliths 10 years ago. We have taken 10 years of framework experience, building experience, and put it into creating something completely new, trying to solve the hardest of framework development problems in the Java space by starting off with a clean slate, by leaving behind legacy, by looking at the problem from a new angle. And we believe that Micronaut is the future of the way applications are going to be built in the JVM in the next 10 years. And ahead of time compilation is absolutely critical for that, and for achieving low memory footprint especially. You can certainly maybe achieve better startup time with soft loading and whatever else, but you will never achieve low memory footprint without it. And Micronaut 1.0 is available now. We, in fact, 1.0.1 is out. So that gives me a little bit of time, and the screen is ready for Q&A. Thank you very much. Questions? Yeah.
You showed that it takes less memory, the application, but how much would the same application take memory without Micronaut?
So it depends if you're talking about a Spring application or.
The same one you had in the example, you showed that it took only 16 megabytes of memory.
Yeah, so it actually got it down to 7. It was on the normal JVM, 7 megabytes max heap. Without Micronaut, well, a typical Spring Boot application, you need at least XMX 24 megabyte or above. Realistically, you need XMX 32 megabyte. And I've had folks from Jakarta EE tweeting me and saying, yeah, but my Jakarta EE app starts up instantaneously with XMX 32 megabyte. And that's great, but that's not what we're, XMX 32 megabyte is not impressive. Yes?
If I were to convert my Spring Boot applications now,
Yes.
what are the pain points or risks? I mean, are they conditional beans? What would go wrong?
So we don't implement all of Spring. That's we have a subset of Spring. Things we don't implement are things like spell. Spring expression language is not implemented. We have no current plans to implement that. We think it's a runtime overhead that is not worth what it offers. There's things like if you're doing a lot of aspect J, dynamic point cuts, crazy stuff like that. We don't support that because, again, it adds unnecessary runtime ahead to the majority of applications, and the small percentage of applications that you may want to do that, it's not worth the overhead. If you have a lot, we are working on support for it, but we don't have yet support for Spring Data. So if you have Spring Data repos, you would have to replace those with manual repository creation. But all of that will be closed that we'll be closing that gap for all of those things. Well, repository support and some stuff like that over the next few months. But the key thing here to remember as well is that the separation between Spring, the library, and Spring, the container, the dependency injection container. And so sometimes people have hard decoupling those. There's no reason why you cannot use any Spring library directly in Micronaut. In fact, for transaction management, that's what we do. There's some amazing libraries for Spring out there, and they're great. There's no point in throwing all that investment away, and those are absolutely usable in Micronaut applications. You can use those today, and with Micronaut for Spring, you can even use them existing Spring configurations in Micronaut simply by recompiling them. So absolutely, there are challenges, but I think it's about the question you have to ask yourselves is in a microservices environment, how much Spring do you need? Yeah, and then the other thing you have to remember is that in a microservice federation, one of the nice things about it is that not every application has to be Spring. So you can have one application that maybe does some really complex stuff and needs whatever aspect J and whatever like crazy stuff that you need from Spring. But the rest of the federation don't have to take the whole memory hit. That's the nice thing about it. It's modular. You can build out a microservice architecture and have that application in Micronaut, that application in Spring. They register with console. They talk to each other over HTTP. Not every application has to be the same, right? I think my time is up. Or is there time for another question? Yeah.
What is the disadvantage of using Micronaut Spring compared to Micronaut only at the moment?
One disadvantage. If the Spring dependencies are compile time, then your jar size goes from 12 megabyte to 30 megabyte. But if they're compile only, then it shrinks back, because essentially if you only use the annotations, it can be compile only. Then it goes back to 12 megabyte. So that's the only real disadvantage I can think of. Is if you start referencing Spring APIs, your jar size will increase. But the idea is that like I said, one of the biggest innovations in Micronaut is the decoupling of the source code representation from the runtime representation. So use whatever DSL that you make. You can write your own annotation mapping and go crazy. Yeah? OK, thank you very much. By the way, there's a whole bunch of swag here. If you want Micronaut stickers, there's loads. Stickers, badges, Grails, Groovy badges as well, a whole bunch of stuff. Please do grab some swag. We have limited supply, so do grab.